Hey guys, Pankaj here. Welcome back to my YouTube channel. So today we are going to start another library, that is Spacey, which is heavily used for natural language processing. So in previous video you saw, right, NLTK, how to use and what are its limitation, and it is basically heavily used for research purpose, right? So there are a couple of problems in some of the functionality which has been overcome in the Spacey library. And Spacey not only supports some good functionality, it supports a lot of different language model as well. Okay, and it is one of the a very fastest library for doing any kind of text processing. Okay, so let me show a couple of things here. I'll tell you why exactly it is used heavily and what are the main benefits of this particular library. Okay, so yeah, so let me open the Spacey library first. So its name is spacey.io. You can read a lot of documentation about the Spacey library, but I'm going to highlight very core feature and most important feature in this, and which once you understand that will help you to understand the Spacey library better, and you will start loving it. Okay, so those reasons I'm going to explain. So if you go to get things done, right here, these are the things which is supported in Spacey, and what are the main things which is everything mentioned or well documented here. Okay, so the main thing which I would like to explain is pipelining, and this is one of the very fascinating reason like why you should choose the Spacey library for any kind of text processing. Okay, so if you see here, right, let me explain over whiteboard, then it will clearly help you to get more insight about Spacey. What is that? Yeah. Okay, so let me use this. Okay, so in this case, right, what is happening? First, I'll tell you about what we were doing in NLTK, right? Natural Language Toolkit. So here we were getting any kind of text, and this we were processing for word tokenization or sentence tokenization, correct? And later, so everything for word, there is a separate function. For sentence tokenization, there is a separate function. And later you will do named entity recognition. Okay, and after that we were having part of speech tagging, then what is it, PUS visualization, NER visualization, what else? Okay, chunking, chinking, all those processing we did, right? And for everything or every small thing, there is a separate function to do that, right? Chunking and chinking, etc. Correct? So whatever processing you are going to do, right, in NLTK, for everything there is a separate function. But what has been improved in the Spacey? Let me just talk about this. So in Spacey library, what is happening, right? You have got the text, or rather I would mention it is a raw text, correct? So raw text will be given to separate set of blocks. Okay, so let me just mention those blocks. There will be so many blocks, and each block contains what happened. This raw text will go to, let's say, NLP, that is natural language processing. So it will do a lot of processing. Then it will go to, let's say, POS, part of speech tagging. Then it will go to NER, that is name entity recognition. Then we have something called token to vector. This I'll explain later. Okay, and so on. So this particular thing is known as your pipelining process. So the whole text will be processed and given to this particular box. And finally, you are going to get an NLP object. Now, once you get this object, right, you can do whatever you have been doing in NLTK. Just use this object and just get all the things. Let's say from object, now it is object, right? It's about a lot of separate functionality or a lot of attributes. So you will have NER, then you have POS, then a lot of Boolean related attribute, like whether it is stop word, whether it is alpha, okay, whether it has punctuation, okay, then what is and then part of speech tagging, then you can filter NER entities. This comes under ents, that is nothing but entities, okay, and so on. So these are few basic things which we have done in NLTK. Same thing we are going to do with Spacey also, right? So as I mentioned, let's recap. You are doing a lot of things in NLTK by using small functions, right? But in case of Spacey, you are passing or processing this particular raw text to a block, which is known as pipelining. Let me just mention. And pipelining is nothing but it is set of rule or set of blocks, consists of set of blocks where every raw text will be processed and it will be passed to the next block. The next block will do its job. So like first block will do some processing, another block will filter all the PUS, another filter or another pipeline block will do named entity cognition, and some more block will do some its job, right? So this is kind of thing which is already fixed in what to say pipelining object by default in the Spacey when you load it. Now good thing about this pipeline, right? A user can add any kind of extra processing block. Okay, so user can add here, I'll mention user defined block UDB. Okay, another user defined block. Okay, so this is 1, this is 2, similarly and so on. So many blocks can be added. Not only addition, you can remove the existing blocks as well. I don't want to go with NLP, I don't want to go with POS, I don't want to go with NER, I don't want to go with token to vector also. Okay, but I want to go with, let's say, user defined block. Okay, so this kind of bigger functionality has been added in the Spacey, and that is the beauty of Spacey library. Okay, so I will explain everything about this, like what is happening when you go with the default pipelining, what happens when you add your own block of processing, what happens if you just enable or disable this problem. Okay, enable or disable this particular block. Okay, so what kind of processing will happen, what kind of processing will not happen. So those kind of things you can easily find out once NLP object is created. Okay, so we'll see everything in the example, then you will easily understand what is happening in the pipeline. And this is very important concept because this kind of pipelining concept we are going to add in the machine learning algorithm also. Okay, so whenever you get the machine raw data for the machine learning problem, right, you create your own pipelining, give your raw data and get the meaningful data out of processed output. Okay, so that's about Spacey. Now let's go back to our Jupyter notebook. Okay, so this is what is explained. Okay, so giving the text root here, let me just open this. Okay, so this particular block is your text, and what else we have? Let me control the pointer. Okay, so this is your NLP block. This is what I was telling. The whole thing is your pipelining, and finally you get the doc. This is nothing but your NLP doc. Okay, so once you got NLP doc, you can do whatever you want. You can do tokenizer, filter token, filter a sentence tokenizer. You get named entity recognition. You get the lemmatization. Okay, and you can get the normal text also. So this is what we are going to see. Okay, now let's close it and go back to our textbook. Okay, now how to load the Spacey library. So first of all, you go here. Either you can run command prompt or you can run the Jupyter by using magic operator, that is exclamation pip install Spacey. I have already installed, so it will just show a requirement already satisfied. So don't worry, if you have not done, then you can easily do that by running this command. Okay, so I'll just leave it. Okay, once this is done, you need to do certain more thing, which is nothing but loading the English language model. Okay, so this name is Core Web SM. Okay, so loading this, definitely you need to have internet. So just go ahead and run this particular command. Let me just comment it. So Python -m Spacey download English Core Web SM. Just run this. It will take some time. It will build. So until you have this particular language, nothing is going to work. Okay, so make sure that you have it, then you are good to go. Okay, so you can load the package via this. Okay, now it is done. Let me comment. I have left it for you guys. You can just uncomment and run it. So to read more about English Core Web SM English model, you can just go to this website. Okay, the one which I showed here, everything is mentioned. Okay, so all you need is Spacey library, then this particular English model, And under the Spacey library, couple of more functionalities are there, like Spacey, which I will not show today, maybe in the next video, to do the named entity recognition or POS visualization. So which we did in the NLTK part, right? But it was not very user appealing, right? It was not so good. Visualization was not so great. So Spacey will make it very easy, and you will love this library when I show the Spacey part. Okay, and after that, you have stop word is also there. We saw in NLTK also, Spacey also had its own stop word. Okay, then this attribute is ortho, basically creating the word count. Okay, so there we saw frequency count, right? Here it is orth. This orth comes from orthography terminology, basically maintaining the hash table of all the existing English words. Okay, so now our library is loaded, and what is the version of Spacey? We have 3.2.1. We have loaded the English language model also. Now let's go ahead and take some text. So this is the text which I just got from internet. You can go to wiki page and just add any random text. Okay, so commercial writers know that most people don't want to read 1,000 words of closely spaced text in order to see some blah 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 I have added. And at the end I just added I need $1 million, something like that, to show you guys named entity recognition, like how beautifully it filters $1 million as a money. Okay, now let's see how to get all words from text. So just create a text. Now, as I mentioned in this particular pipelining, right? So what is the first step? You need to pass this text to NLP, right? So NLP we have already installed here. That is Spacey. Okay, so let me just show here quickly. So what you need to do, you need to create the NLP object. Okay, so where is NLP now? Where is that? Part-1. Okay, NLP dot text. Let's say it is going to create object. Let's run it, and let's see what we have in the object. Okay, so this is basically object which is by default printing the whole text, right? But this itself is not a directly text. Okay, this is nothing but an object, because you cannot apply any of the string method in this object, because this is not a string. This is some other object that is known as NLP object. Okay, so if you want to convert it to text, we have something called dot text. Okay, dot text attribute will return the text. So how to get all the words from text? So what we'll do, we'll iterate over it. For w in, let's say, object print w. It is going to print, but let's see what is the type of w. And I'm just going to break it. See, this is not a normal text. Okay, it belongs to class Spacey token dot token dot token. It's basically word token. Okay, so once you have the token, right, its object type is token type, right? So you cannot apply any string method. You need to convert to direct string. Okay, so for that, what you can do is, as I mentioned, a lot of other attributes will be there. So w dot, we have something called text. Okay, so this text is nothing but a normal string. Okay, guys, so that's how you get it. And maybe I'll just print a space. Okay, it is printing everything in the next line. That is fine. So these are this is the way to get separate word in the form of word token. Okay, so find out the stop word. So as I mentioned, if you see in the library, right, so what they are doing, they are doing a lot of tokenizer, tagger, parser, NER, right? Everything is done here. All you need to do is everything is available in the form of attribute. So just go ahead and find the attribute. So how to find the stop word? So now we have for w in obj print. So what we can do, w dot is stop, w underscore sorry dot is stop, because stop is another attribute because it has gone to tokenization, right? Okay, so what it is going to print, let me just print in the form of double. See here, commercial is a word. Is it a stop word? No, right? That's why we got it false. See how beautiful it is telling that it has already processed all or each and every word from the raw text and maintain those tags. Okay, so you can just filter it. So now you got the logic. Is stop is another attribute which will return boolean true or false. So how to filter it? What you can do now, I'll create a list comprehension for w in w dot obj if w dot is stop equal to false, or maybe I just want to extract all the stop word, right? You can just do that. So if it is true, then return all the w. See, these are your stop words. See here, that, most, do, not, do, of. Okay, and how to filter other words? Just make it false. Means I want to extract all the non-stop words. This is the list of all the non-stop words. Okay, so this is very simple. I think you should just run one or two problem and you'll easily understand what are the things supported. If you want to support get all the list of supported words or attributes or function, right, just write print dir of obj. Okay, so see here what and all it has. It has lot of functionalities are there. I'm not going to show you guys everything, but couple of things which I wanted to mention is like text, which we already saw, w.text. Then we have something called ents. So this is nothing but your entities. So whether it is belonging to name of the person, or maybe company name, or maybe dollar value, or maybe cardinal value, that is normal date or number, correct? So similarly, you have so many other things. You can just give a try and just understand it. Now let's go ahead with another part here. So create an NLP object of a given document sentence, correct? So given document to be converted into sentence. So what we can do, we have NLP print text is there, right? So this is one of the complete document, right? So multiple paragraphs are there. It could be multiple sentence also. So how to convert into sentence? So what we can do, del w equal to nlp dot, okay, so nlp dot text. Now for sent in w dot sends. Okay, so w dot sends. So why this sends attribute is there? Because if you see here tokenizer, it has already gone to tokenizer block. And from this block, it has converted to word tokenization or sentence tokenizer, right? So for that, we have direct attribute called sends. Now just print s. See here, there's one sentence, there's another sentence. Okay, so that's how you convert to sentence. Then from all the paragraph, you got all the sentence. From each sentence, you can make it to word tokenization. Okay, so multiple ways to do that word tokenization. To create separate word from sentence, how you can create separate words? So you pass this to, there are multiple ways. One, you can do either space separated. So first you can do is, now text will also be there, right? So because this is a token and I want to convert to normal text. So one way what you can do, each text you can do the split dot space. So this is one way of doing the word tokenization. This is another way. Other way we have already seen here, w.text, this has already done the word tokenization, correct? So after getting the sentence, what you can do is, I will pass this particular sentence to nlp dot, let's say word equal to, now again pass nlp and give this particular s dot text. Okay, and for word in w, print word dot text. This is also fine. This is what exactly we saw on the top, because the whole block has been passed already, right? That is a tokenizer. So it is already maintaining word tokenizer as well as sentence tokenizer. So it is up to you guys, whichever way you are comfortable, you can just do that. Okay, so let's see the next one. To create separate word from sentence, we already saw it. Now let's see the next one. count frequency of each word using hash values. Okay, this is what I was telling. ORTS is nothing but it comes from orthographic terminology. Okay, where we maintain each word in the form of hash table, because it's a very big chunk of English word or English vocabulary, which is coming from this particular English model. Okay, so this file size is almost close to 15 MB, and you can imagine how many words will be there. Everything is maintained in the form of a hash table. Okay, so let's see its example now. Count frequency of each word using hash values. So let's see that. No. We have something called OBJ we already created. And let me create once again. OBJ equal to NLP dot text, right? This object is created. Okay, so for let's say W or maybe D in PJ dot count by. So count by will take self attribute explainer. Okay, I think we can pass as ORTH because that is the function we have already taken, right? So where is that? You see on the top, I have already explained. Yeah, I have already imported ORTH functionality. All you need to do is just pass ORTH print D. Okay, see here, for every word you see the number, right? This is nothing but the hash number or hash ID of that particular word. Okay, so by default, whenever you are going to print this kind of detail, like it is going to give a number, because that's what Spacey understand, number, because everything is maintained in the hash table or maybe some kind of dictionary key and value pair, right? So you need to convert these number into a meaningful word, okay, which is already stored. So how to do that? So where is that? We have one function called, let me just write it here. Why it is not printing the thing? It has created D. So what I will do, D equal to this, print D. Okay, yeah. Maybe if you want to see it properly, you can just do it this way. So if you see, right, commercial is one word which is maintained in the English model somewhere, and its number is nothing but this one. Okay, and its count in the whole text is just one. Okay, and there is another text which we'll see shortly, like this particular number belongs to which text. Okay, so we'll do that, and its count is 3. So let's find out what is the text and why their count is number 1, 2, or 3. So we have something called, now D is a dictionary, right? So under this item, we'll just do the item, so which is going to return key and value pair, correct? So once we get key value pair, we have something called nlp.vocab. In that vocab, we have string function, and if in that string, if you pass this particular number, right, it is going to return with a string of that particular number, or basically a direct English word of that number, and value anyway you already have it. Okay, so let's run it. Now you'll see. So commercial, it is existing 1 time, writers, and 2 existing 3 times. So you can just see 2, 3 times. So this is 1, this is 2, and there'll be one more somewhere. Where it is, it will be one more than, yeah, 3. Okay, so total 3 times it is existing. So like that you can get all the count. Okay, and what is other or best way to do that, or maybe simple way to do that in case you don't remember all those things? So what we can do, text we already have, right? So I'll just create dictionary word txt dot count w for w in txt dot split. Okay, so this is another way to do that. So if you see 2 exactly 3 times, so whichever way you want. So Spacey does provide a lot of other functionality, but still for, I think for word count, I think dictionary comprehension is the best and right way or very optimized way to do that. Okay, so that's about this. Now let's see print index of index and offset index of each token. So how to do that? So we have already seen object w equal to nlp txt, correct? We got this. Now for word in w, print word dot text. Yeah, all good. So let's print in the form of tuple. What is its id? Let me just explain. Word dot I. Okay, and we have something called word dot idx. Word dot idx. Okay, so what exactly this I and idx is? So let me just write. I stands for index of a word in parent string. IDX is nothing but, you see here IDX is little more, right? So this is going to, okay, so commercial is 0, then writer exactly at 1. So IDX is nothing but offset from the parent string. Okay, so let me just explain how it is working. So I'll use pen. So if you see here, right, this count is nothing but, just reduce the size. Okay, so yeah, this particular commercial, right, this is exactly attached at 0th index, right? Now writer is what index? It is at 1 index, correct? Similarly, no is at what index? It is at 2 index, correct? But their offset is from the beginning is what? So this number will start from 0, correct? 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. Then this is 10, and this is your 11, correct? Then 12, 13, 14, 15, 16, 17, 18, and this is from 19. That's what you see here, correct? So if you see the no here, no is started at 19, writer started at 11, and commercial at 0. Okay, so this particular thing is offset, and the first one is your index. Okay, so remember guys, the difference between I and IDX. Okay, so that's how you get the IDX. Now let's see a couple of other things which is very important, and it is like available off the shelf. You can easily work on it. Print various attributes of an NLP object. Okay, so let's see that quickly. What exactly it does. For W in maybe word, I'll use previous in W, print word dot text. Okay, so let me create everything in the form of tuple. So I have dot text. Now word dot, I can use shape. So what is the exactly shape? Shape is basically what happened here. Let me just open the notepad. Yeah, so let's say you have something called apple. Okay, sorry, you have APPLE. So what is this shape? How the shape is getting determined? So this capital letter will be represented as capital S, and all small will be small letter. Okay, now let's say you have BANA. So first two letter is capital X, third letter is also capital, another thing will be small. This is the shape of banana. This is the shape of apple. Let's say you have SCHOOL. What is the shape of school? So we have capital X, small x, small x, small x, small s, capital X. This is the shape of the school. Okay, so that is what this Spacey library, right? I will keep telling you will start loving it because it maintains a lot of internal details about each and every English word. Okay, so shape, as I mentioned, by default, the name will have the index or the hash value of that particular shape. But if you're going to run word dot shape underscore, it is going to return the exact shape. Okay, shape underscore. You see here, commercial, commercial, Okay, so I think first 5 or 6 character will be shown. And that's how it is maintaining. Okay. Now what is, we can print whether it is alphabet or not. So we have word dot is alpha. Is it alphabet? Yes, all true. Wherever you see number, it will be false because it is not alphabet, it is numeric value. What else we have? We have something called word dot pos. So again, pos will have some number because like noun, preposition, or adjective, conjunction, all those things, right? So to see exact name of that, word dot pos underscore. See here, first one is your adjective, writers is noun, know as verb, then that is subject, conjunction, something is there, adjective, people is noun, do is auxiliary, part, like that. Okay, what else we have? So we can have the tag also, word dot tag. Tag again, it's a number. So I'm just showing you guys everything so that later you can just filter whatever you don't want. Okay, so this is JJ, NNS, VBB, all those things. Okay, now if you don't know what is the meaning of it, so what I'll do here, I'll just quickly show one functionality. Okay, so for word in W print, we have something called Spacey dot explain, and if I'm going to get the meaning of each tagging. So I want word dot pos. See here. So what you can do is maintain this as tuple word dot pos underscore. Yeah. So ADJ stand for adjective, noun, verb. Okay. Get meaning of pos or tag. Okay. Similarly, what you can do? I had tag also, right? So let's get the meaning of tag also. So adjective, noun, verb, conjunction, subordinating, or preposition, adjective, noun, auxiliary. Okay, so beautifully you can represent the whole thing in the form of this object and filter the attributes. Okay guys, so yeah, that's all for today. I think this basic is good enough and you guys can practice, and let's see the next video. I'm going to explain like how to filter named entity, how to display the part of speech tag, named entity recognition, okay, and a couple of pipelining concept. All those things we'll see in the next video. I hope you liked it, and I would suggest please practice more so that you can start using it whenever you handle very large set of text data. Okay guys, thank you so much. Bye bye.